Welcome to the electronics side of the shop. First up, the work on the blue DRO tachometer continues. I suspect the problem is noise because when the mill runs, it's tearing up the AC line, which goes right through the little transformer power pack and goes right into the blue DRO and tears up the ground and 3.3 volts. So I'm waiting for a 6-volt battery to prove it. In the meantime, I keep forgetting to mention the user manual for the touch DRO and the blue DRO I have posted on the website, which is shown in the splash screen at the end of every video, the link to it, theminimachineshop.com. It's in the technical section, so feel free to download it. Next up, I'm going to kind of relax a little bit from producing a video every Friday. I need a little bit of a break here. Today's will happen and next Friday's will, but I'm not sure what's going to happen after that. So there may be a video coming up Fridays. There may not be. Please don't be disappointed. So what you see here is a 3-axis CNC. It's $250 off Amazon, and I'll put a link to it in the description. I think it's a fantastic product. I'm having a blast with it. It's not supposed to be doing aluminum, but I'm having a good time with that. I do still need to refine it more. There's quite a bit more work, but what you're going to see in this video is assembling it, and I'll be talking. There's too many silent videos of people just putting it together and nothing. So I'm not going to show, ridiculous every single step of it and fast forward it and all that stuff, because a lot of it's obvious, but I will give comments here on tricks and things to assembling it that make it a lot easier, and how to square things up and so on. Next video, I'll be getting into the software for it. I've downloaded a lot of free programs. Some of them are a complete joke. Some of them are really good. Let me also mention, it came from SainSmart, which you'll see on Amazon, and I did find a website for SainSmart and did contact them through their website asking for a direct email or something to somebody in support, so that if I get stuck, I told them who I am, I'm doing videos, if I get stuck, and it took 48 hours for them to respond, and they are in China, because the English was not that good. I couldn't even understand what they were trying to get at, because I had emailed them after they said, after I contacted them and they said, oh yeah, just email here and we'll help you out. And then I emailed them a problem and the answer was like, huh? So whatever. And I just emailed them again this morning. Where do you buy spare parts? If something is defective or you need to replace something, where do you get the parts from? I bet you there's not going to be a response. I don't know. But in any case, so next Friday will be the software, what I've learned so far. I still have a long ways to go, but I think it's a great product. So I guess that's everything I wanted to say. Okay, yeah. So enjoy the video and see you next Friday. All right, this is going to be really interesting. Do I raise the camera or lower it here? Lower it. Big box, heavy. He's putting it lightly. This is all because Paul sent me the YouTube video that had that ER11 chuck. So this guy, I figured, CNC, I might as well do it. It's going to be a lot of work and a lot of figuring out, software-wise, hardware, control. Jesus, okay. That's interesting how they do that. Yeah, can I get it out? No. Hey! Hello. Alright, as I struggle with it, because it is pretty darn heavy. So I have something to do new and a little bit more fun. Been kind of getting burnt out doing this tachometer for the blue DRO. Think I have it finally figured out after 4 weeks of flailing and redesigns. And there it is. You can see the picture of it. I'm going to be a kit because I figured I can always, since I have a mill and a lathe, improve it. Where's their little chuck? Oh, here it is. Because the first one I bought that I did show turned out to have like 17 thousandths run out. So I returned that, bought another one from another source. This one looks pretty good. Hopefully it's fine. So this must be the one collet, huh? What did they send? Oh, I'm sure they sent it for these bits. Be interesting to look at the bits. So a whole bunch of stuff to play with. I can't even read what it is. Oh well. Nuts, bolts. Why they give this? That's scary. This is supposed to be, this better be 110, 120. And whatever these guys are. Well, I'll have to play with them off camera and look at them. So a lot of work to do, and I can always increase the z-axis travel. Like I said, this is just a basic get me going. If I can get G-code going and a CAD-CAM program going other than Fusion 360, which is just way too complicated. I don't want to spend the time to learn it. Yeah, cute little couplings. It's a heavy motor. So you'll see this guy in upcoming videos. Cute little motors. I'm sure they have a lot of torque to them. So there it be. Oh, the giant power pack. Alright, I thought I'd better come back and record this. This is an incredibly heavy table. And it's pretty darn big. So it'll be interesting. I'm going to try doing aluminum on it, but I'll beginning with plastic or wood or something just to get things going. But wow, so it is, there's a lot of quality stuff in here. And these rails, they're like glass. I've never felt anything that smooth. So this is going to be really interesting. The lead screws are perfect. You know, this is like this thing was made in the United States. Incredible. Bearings are in here, right? Because I thought it was just plastic bushings every place. Let me get one out. Yeah, that's a, oh man, there's little ball bearings in there. So this is not, ooh, it's greasy. This is not really a cheap thing like I was imagining going to be, and then I was imagining machining up parts. This is great, guys. Notes on the assembly, because I did watch a YouTube video on some guy putting this thing together. They do give you instructions. They're very clear. It's metric, but it's easy to Google a converter. So I've got wonderful pictures here that are very clear to put it together. Secondly, all the pieces come with this clear stuff on it so that when they put them in the box, it's just on two sides. They don't wind up scratching one another up. Pretty easy to take it off. So that's the second note. I mean, they really did a quality job here of packing this and manufacturing it. Next up, I saw the guy in that video putting it together, and he was using teeny little tweezers to put these guys in the slot, and he's fighting it. It's really easy. I mean, you just pre-assemble it this way, they drop right in, and when you turn them, they lock in place. So it's really easy to do, and they don't really come back out. If I can get that guy up. It is a little bit of a challenge because they're so small, and I should cut the angle off of this Allen wrench so that I can just spin it real easy. There, that one just locked in place. And this one, let's spin it. And there it is. Yeah, this is still loose. I got to get the dimension on it. So that's a quick little shortcut. Makes it a lot quicker to put this thing together. Makes the 30-minute mark. like I said, these screws too seemed like they were way too short, and I was a little spooked, but they work. And again, you just drop it right in there and spin it. I had one that I had to back up on because it didn't spin right. Did I do this bottom one? No. See, all locked in. So pretty good. You know, I'm not tightening them down because once I get the rods in there, then I can align it and make sure it's all straight and square. On these screws, I wouldn't crank them down real hard because you probably risk bending this aluminum here. It's pretty thick, but still. So pictures are kind of okay. I had one stumbling. I thought these went here, and then you just come and look at this picture and you go, oh yeah, this is just clamps here. So it's moving along. 30 minutes so far. 1 hour into it, not counting a tear down or reassembly, but I'll explain. Tips you're going to see here and not in any of the videos that I've watched on YouTube. First, do pay attention to the lengths of all these pieces here. I didn't. The shortest ones are your vertical, the next shortest are your depth, and then the 5 long ones are all the width of it. I had it all wrong, so I had to completely tear this thing down, put it all back together. So next, putting this together is the most miserable thing because you need like 36 hands to hold this, that, and all that. How do you square it up? With everything loose, bring it forward is what I did, and lock one down, and then lock both of these guys down. One screw on each of the underneath pieces. They're pretty long, so I'm thinking they're going to stay parallel. So I've got that locked, and I measured, and bringing it all the way back, it did pull the rod straight. So I measured here and I measured there, and they're as close as I can see. I do figure, you know, how do you gonna get this square? They figure this is kind of a toy. Eventually, I know you gotta loosen, tighten, and I'll get this thing really square for milling over time. So back, tighten that down. Now just tighten the other guys down, and I still haven't tightened the back ones down, but it seems pretty good. I mean, there's no side play. Their quality is great on it. This guy also is miserable to put together. Just basically get the rods on the head, and then what did I do? Kind of just tightened up or snugged up these two guys. Then I could put a flat thing here, bring this guy up till it's flush, lock him up, lock him. Now you can bring it, I've got this in there, so I can't do anything yet. Bring it to this side, lock everybody down, this side, lock everybody down. The next thing that was a kick is they tell you in the picture this piece and the spring, and just you assume you just screw it together, but then you just bottom out, and it's like, huh? And there's holes in here, so I was thinking this gets screwed down. But what you do is you got to put the spring in there, compress this together, and then start running your lead screw in there. So, and it's impressive here that they've gotten rid of backlash. What's this noise I'm hearing? I'll have to grease it, but oh yeah, this guy is rocking in here. So be interesting to see. I may wind up doing something if that's a problem with backlash, but very impressed with this. What else? Trying to over here account for parts and screws and stuff. You can see I have a lot left over as far as I can tell. Everything's accounted for. And these two guys, they don't show you in the picture or the manual anything about where they go. And I think they go underneath here. the picture clearly shows nothing there. So I don't think they gave spare parts, but there's that. These guys too, it's interesting, the picture, where's the picture of that? Oh, there it is. Okay, 2 grub screws, and the X means don't put them in, because there are 4. There's 2 on this side, and you flip it over, 2 on that side. And it came with all of them. There's some spare parts. I do have a spare screw for the motor in case you lose one or drop it or something. And there's 1 spare grub screw. And if I'm not supposed to put those in, then I've got 4 or 5 spares. But whatever. And I heard about this. This is the one that came with it. And I've heard a bunch of people say it does not fit, and yes, it does not fit. Even the one that I bought separately does not fit. So I'm not sure how I'm going to solve that problem yet. And heads up on this guy. I'll open it up, but wow, I was lucky I didn't get stabbed with these things. These things are like, chew. What it is, if I can get one out, I gotta put it down. These things are incredibly sharp. As you can see, it's like, wow. If you have your finger here and you put it on, it's gonna go right through, and it goes into your finger. Luckily, I had it like this, and I pushed it on and saw it poking out and went, whoa, that would have really hurt. So heads up on that. And so, just like I said, I'm just taking a break, trying to look at it. I know, I haven't tightened these down yet. They give you what, 1, 2, 3, 4, 5 different Allens for this thing. These are tough too. I don't know why these things bind. Some of them did, some of them didn't. Yeah, they're like off center or something. I don't know what it. Yeah, see, it's like. Ah, man, I can't even get it in. So I may wind up drilling, retapping, doing something with those. So I think it's pretty cool so far. There's a lot of parts here. If you were to build this yourself, this would be crazy. Oh yeah, now I gotta try to get that all pressed in and then run the screw in there. Alignment, yeah, like I said, I know it's going to be playing with it over time. Tweak here, a little tweak there. But, I don't know, $250. This is a lot of stuff. And I would definitely say it's a lot of pretty quality stuff. Is it going to come out yet? There it is. Oh, now I got to get this guy all the way down there. Oh, actually, I got to get him off. No. Yeah. Hey, come on, go. And I'll be greasing all this stuff up. So that should be far enough. That's that. Push it in there. And then try to thread it. There it goes, I think. Yeah, it caught. Alright. So that's the trick that nobody shows on how to do this. Or I didn't go back and watch that one video of the guy assembling the entire thing. He probably did show this, how it was done. On the collet chuck, many have asked, or I've seen in a bunch of places, I'm not sure where, but this is advertised as being a 5mm hole, and I've seen some people saying that they can't get it on the spindle here, the motor shaft. The motor shaft, if I use the precision mic, is 5mm. Using gauge pins, I figured out the hole is about 2/10 undersized. I know some people have used the press, an arbor, and pushed it on there and risk screwing up your motor, but 2 ways you can solve this thing. The first correct way that you're supposed to do it is you're supposed to heat this thing up to 300 degrees Fahrenheit to expand it, and then you just put it on. So that's the way it's designed to work. Second way is, for me, I just simply took a 5mm end mill, I put it in a chuck, I hand ran it in to keep from messing up angles or anything. So I ran it in this way, and I ran it in from this end too. So that barely took out, you know, the 2/10 of a thou, and then I was able to, it's hard, but I could push it on and I can actually pull it off by hand. There is Zippo run out in it after doing it that way. So you can either heat it up or you can use the end mill approach and get it installed that way. Turn it sideways so you can kind of, which way do I gotta go? This way. See more of it rather than just the other direction. Comments on it, very impressed with it. Like I said, all the hardware, screws, washers, everything is of high quality. And comment on this, I mounted this motor the other way. You want the connector on the top, connector on the back for that one. And what else was there? It does come with software as a little disc, and I did do a lot of research on the CAD CAM stuff. So everybody saw before I tried to CNC my mini lathe and quit because of the complexity. You need a CAD program to do the design, computer automated design. That has to be compatible and ported over to a CAM program, computer automated machining, which generates the G code, which then you pass over to your controller, and then it runs. So the software that it came with, the pictures of it in the manual, is the one I was hoping to get. There's a lot of free software out there, and I hadn't found that one. So I've got the program that controls this. And I have seen free stuff that's both CAD and CAM together, and I pulled one of them. One of them is called FreeCAD, and another called GCAD, and they're not as complicated as Fusion 360, which I've tried a few times, and it's like, man, I don't want to spend my life trying to figure it out. And I saw in the video somebody did a Fusion 360 design, and it popped right into these other programs. So now the next step would be load up this program and just kind of get this thing moving, make sure that that's okay. The only play I can feel is just slightly here. I can feel the spring in there, so I may have to come and tighten that up. But for doing plastic, wood, whatever, I went into this because I can grow. You know, this is like proof of, can I do a design and have it come out? You know, the whole thing fluid and working. And if I can do that, then I can easily modify this for more Z travel and blah, blah, blah. But for $250 to do this, and if I can get this going, this will be fantastic. Control board, it does have a connector for a laser. I can put a laser on here if I want. I've seen on Amazon and different places bigger motors, stronger motors, so I can start doing a lot of different things and grow with this over time. I can do, I guess, etching if I want to write something, engrave something, all kinds of things. So big learning curve for me, and it's going to be fun. So next step, hopefully I can get this thing fired up to my laptop, because the other one was, I can't believe it, it's all over eBay too. These guys, heavier duty, but they run, I forgot what you call it, oh shoot, it's a controller board that I bought, but it needs a parallel port. What computer has a parallel port anymore? None. Big pain. And you can't add in just a parallel adapter. It doesn't work, because that's only one-way communications, and you need two ways. That was one of the other reasons why I quit trying to CNC my lathe. But, oh wow, I'm very impressed with it. It's incredibly heavy. It really is when you finally get it all together. So let's see what happens from now.